Hello and welcome to my video, lesson 3.6 on independent event probability. So my hint to you is just like 3.5, you should be using tree diagrams. So if you don't know what that is, maybe take a look at 3.5. Otherwise, you can also continue on with this lesson. So we have two questions here. It's just going to be a fairly straightforward lesson where basically independent events are events that aren't dependent on each other. They don't matter what happens in event A to affect event B. So for example, if you have a child that is a boy, okay, a baby boy, what is the likelihood of your second child being a boy? Well, it is still a 50-50 chance. Event 2 or event B, event A, they're the same. It doesn't matter what happens in event A, event B is the same chance, regardless. So let's take a look at these two examples, and they are both independent events. So rolling two dice, what is the probability that you will roll one dice as an even number, one die? Rolling two die, what is the probability to roll one dice? I think that's how you say it. Dice is a weird word where singular and plural is different. Anyways, as an even number while the other is a 5. So the first is an even number, the second is a 5. So let's take a look at the possible outcomes. So the first two choices is it could be an even number or it could be an odd number. Here, the deal here is that it's just the probability of each is just 1/2. You could go through and take a look at them if you want to. I'll write them out and just show that and make it quite obvious. But basically, even numbers I'm boxing, odd numbers I'm leaving. So you can see there's 3 of each. So it'd be 3 out of 6, which we can reduce to 1/2. So anyways, all that to be said, that even and odd are both 1/2 probability. Okay, next, what we do is we ask the probability of rolling a 5, not a 5 is the second part. So 5 and not a 5. Okay, so probability of rolling a 5 versus not a 5, so 5 times 1/2, and you get 5 over 10, which is, not 5 times 1/2, what am I talking about? 1 over 6, 5 over 6, 1 over 6, and 5 over 6, right? So now what we can do is we can multiply them. So 1/2 times 1/6 equals 1/12. 1/2 times 5/6 is 5/12. And then same thing down here. And so what is the probability that you roll an even number and then and the other one's an odd number? Well, there's a few possibilities. Now, it doesn't say this and then that. So what we can also do is just think about, this is actually going to be a relatively complicated version of this. You can think about how this is one dice where it's an even number or an odd number, right? But what if it is an odd number that is a 5? Right? Because now your second dice could be even or odd. Right? So you can see how there are actually more possibilities. So this is actually not 1/2. To be more precise, this would be 1/3. This would be 1/6. And so now what we can do is we can say this is 1/2, 1/2. And so we can calculate those odds and we get 1/12. These ones actually need to change a little bit. 1/12 and 1/12. And then this is times by 3, so it's over 18. 5 over 18, and this is 1 over 18. Now you can see all the different possibilities. See, this is a little bit more complicated because there is a few options here for the first dice. So anyways, now that we've done all of these combinations, which ones are favorable outcomes? Well, if it's even and a 5, that's favorable. So here, and 5 and even, so here. So now we take these two numbers and add them together, and we get 2 over 24. No, not over 24, over 12, which simplifies to 1/6. All right. Now, you should pause the video and try the second question on your own. In a family of 4 kids, what is the probability that they will have at most 3 boys? So 4 kids, at most 3 boys. So we're going to do it with the tree diagram to show you, but you could, I just want to just remind you guys that you could do the whole choose thing. So out of the choice of 2 of boys versus girls. No, because we're not choosing out of it. No, that should be fine. Okay. So anyways, what we're going to do is we're going to branch off per kid, right? So the first kid is there or there, which is boy or girl. Okay, the second kid is boy or girl. Boy or girl. The third kid is boy or girl. Boy or girl. Boy or girl. And finally, boy or girl. Okay, and then the fourth kid, there are, whoops, let's make that smaller. There's a boy or a girl. There's a choice, again, boy or girl. Boy or girl. And you can see how there might be a better way of doing this, but tree diagrams are very, very consistently right. So yes, there are better ways, but excuse me, boy or girl. Okay, so we've gone through and done everything. Now it says at most 3 boys. So what can we do? Well, we can actually just find the probability along one of the lines. So if we go boy, 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 see, we don't need to necessarily draw out the entire tree diagram, but we have here just in case. But with boy, 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 right, it's 1/2 chance that it gets to here, 1/2 chance that it gets to here, 1/2 chance here, 1/2 chance here. So if we multiply all those together, 1/2 times 1/2 times 1/2 times 1/2, this gives us over 16, 1 over 16. So this is the unfavorable. This is if they have 4 boys, which does not fit in the at most 3 boys, right? So if they have 1 boy, 0 boys, 2 boys, all the rest of these branches all fit within that at most statement. Okay, the only one that doesn't is this 1/6. So 1/6 is unfavorable. So if we go 1 minus 1/16, sorry, this would be 15 over 16. So what is the probability that they will have at most 3 boys? Well, 15 over 16. So I hope that this video helps you guys better understand independent event probability, and good luck.